respected venerables, honored guests and friends. I'm very pleased and honored to have the opportunity to speak about what I have learned in cosmological physics and its link to Buddha's teaching about the universe. Venerable Master Jin Kong have mentioned many times when he lectured on the Flower Adornment Sutra. He said that Buddhism is an education about the truth of the universe, and modern science has gradually verified what Buddha Shakyamuni taught in the sutras. These insightful statements have long triggered my interest in constructing the latest physics discoveries about the universe with the teachings in Buddha's teachings. I recently devoted some time in searching America's National Aeronautics and Space Administration's online literature, or NASA. And I have summarized some key discoveries about the universe. As you know, NASA, founded in 1958, is the world's leading research agency in aerospace and physics. Venerable Master Jin Kong suggested that I present these scientific findings to the Pureland Learning College so that we can deepen our understanding about the truth of the universe. Modern cosmology attempts to describe how the universe started and developed. It is built upon Albert Einstein's theories of relativity and quantum mechanics. Most of the discoveries are derived from highly advanced mathematics and are quite difficult to comprehend for a person without sufficient mathematics and physics background. However, it is not necessary to cope with technical details of all these mathematical formulas. What are important here are the messages that emerge from the scientific research. I will elaborate below some key discoveries of space physics research, which appear amazingly similar to what Buddha Shakyamuni had taught 3,000 years ago. So here I would like to present three key messages derived from modern cosmology and quantum physics. These two areas have similar results to those teaching of the Buddha Shakyamuni about the universe. So next, I will try to use simple and easy to understand language to explain and avoid complicated mathematical equations, because I'm trying to present ideas, not research results in physics here. These three key messages are: the first, distance is not real and time is illusory. Secondly, things can be created from nothing. And finally, the origin of the universe. So my first topic is about the notion that distance is not real and time is illusory. To come up with this notion is not an easy task in physics. Although I de-emphasize the technicality of physics in this presentation, the proof of this notion has to rely on Albert Einstein's theory of relativity. Relativity is an outgrowth of Einstein's thoughts in the early 1990s about motion and gravity in a non-Newtonian framework. We know Newton's physics, especially in the realm of mechanics, works well in the dynamics of three-dimensional space, especially for Earth-sized bodies and smaller, and for the objects at velocities common to everyday experience. Einstein's relativity framework, however, is completely different. Instead of the absolute view of fundamental parameters, such as space and time, envisioned in Newtonian physics, space, time, energy, and mass can all vary in their perceived nature in a relative sense. The theory completely altered the direction of modern physics and provided a solid theoretical founding for cosmic research. Einstein was therefore regarded the father of modern science. Both the history of Einstein's discoveries and an excellent portrayal of how they affect cosmology are given in Amir Assesso's book entitled God's Equation, Einstein, Relativity, and the Explaining Universe, published by Dell Publishing in 1999. Because of this great scientific contribution, Einstein was awarded Nobel Prize in Physics in 1922 and was later selected by Time magazine in America as the man of the 20th century. A splendid biography of him entitled Einstein, The Life and Times by Ronan Clark, published by Avon Books in 1971, describes Einstein's contribution as a scientist and humanitarian. There are two stages of relativity theories. One is called special relativity, and the other. Special relativity is applicable to objects that are traveling at uniform velocities. General relativity is concerned with the effects of accelerating velocities. His theory of special relativity was first published in a physics magazine in 1905. In the same issue of the journal, he also had significant papers on Brownian motion and on the photoelectric effect, for which he later, in 1922, was awarded Nobel Prize in Physics. Einstein, among other researchers, realized that physical properties should theoretically change by a great deal when their measurements are under conditions